All right, for this video, we're going to talk about classes and inheritance, specifically as it comes to Unreal objects. So in Unreal, everything in your level, in your game, is a UObject. And the different things that you can make from UObjects inherit from there. What do we mean by inherit? Just like how you inherited something from your parents, the child object or child class inherits from that parent class. Things like variables and functions and things like that, just general behaviors. So the base class is a UObject. UObject is basically everything in Unreal. If it exists in Unreal, it is a UObject. A UObject's job is just to store data. All it does. It stores some information. It can't be placed in a level. Every F vector or F rotator or anything like that, those are UObjects. They're specific classes in Unreal. They can be tagged as different things, giving them extra functionality. Those tags are done through something called macros, which we'll talk more about a little bit later. But just know that everything in Unreal is a UObject. That means if you can do something to a UObject, you can do that to anything else. Then we have actors. So the A is a prefix that's just used to say, hey, this is an actor. Actors will inherit everything that an object has. So it will have all the ability to be manipulated just like an object. However, it gains extra functionality. For instance, they can be placed in a level. An actor has a transform and has a location, rotation, and scale, while a UObject doesn't. Actors can also have visuals attached. And they're programmatically controlled as well, where you can add functionality to those objects, those classes. Then you have pawns. So a pawn will inherit everything from actor, and thus everything from objects, but they gain extra functionality such as being able to be possessed by a controller. So a pawn gains everything that an actor has. So it has a transform. It has the ability to have visuals attached to it. We use pawns for any non-humanoid player-controlled object in a game. Because pawns inherit from actors, you can actually treat pawns just like any other actor. So anything you can do to an actor, you can do to a pawn. Then we have characters. So a character inherits everything from pawn, thus everything from actor and object, but has a special character movement component attached to it. You usually use character for any humanoid player-controlled object in the game, but a key part here is that it is still treated like an actor or a pawn. Now, you've actually seen inheritance take place in our projects so far. So we have the A item. So A item, right, is our actor. Our item is a actor. So we actually can see this inheritance take place here, where we inherit everything from actor into our item. If this said public a pawn, that would mean that our class that we make inherits from pawn, but here it inherits from actor. Now there is a relationship here. Objects are not actors or pawns. They're the base. However, an actor is a object. So actors are objects, but they're not pawns, right? And then a pawn is an object and an actor. So if you go up the line, or up the family tree, or down the family tree, I guess you'd say, you get the is a relationship. So a pawn is an actor and is a UObject, but not the other way around. Then we have the has a relationship. So if we take a look at the structure of an Unreal project, the first level that we have is the package. That's the file you downloaded, basically. The file that you're working with, that is your package. In there, you have your world. So the world is something that is created when you run the code, when you run your package, and you create an instance of the world. The world is effectively the game. In the world, you have your levels. The level is interchangeable. You can have multiple levels if you wanted to, but you can only ever have one world. You can only have one game, but you can create multiple levels if you wanted to. Inside those levels, you're going to have different actors. One of them might be a pawn or a character, but they're still actors. And each one of those actors will have a component or multiple components. So you can say that we have a has a relationship here. Package has a world, which has a level, which has actors, which have components. These are not related. They're not in a family tree. They're not there's no inheritance here. But your package does have a world, which does have levels, which do have actors. Those actors do have their components. Each component, such as a collider or a mesh, things like that. So again, a package has a world has a level, and so on and so forth. Meanwhile, your assets, such as your meshes, your audio, textures, are part of the package, but they aren't part of the world. So it might be more accurate to have these inside the purple area there. But your assets are not part of the world, but they are part of the package. When you download the files, you get the various assets. Next, we have kind of a brief conversation that we're going to have to take up in the next video, but I want to talk to you about an important programming concept called reflection. So reflection is the ability for a program to look at itself and then gather data about itself. This is largely for back-end stuff that's behind the scenes, and generally are things that are made and used to make your life easier so you don't have to worry about it, don't think about it. But C++ doesn't have reflection built in. It doesn't have the ability to look at its own code built in. However, Unreal does. And a key part of this is something called garbage collection. To understand, we really have to dive deeper into variables and memory allocation, but just know that without garbage collection, we end up with memory leaks. We end up with issues in our program when they run over long periods of time. In Unreal, because it has the structure like this, the package world and level, all that stuff, because we can put everything that is running that code inside this package, we have the ability to have a reflection system and thus have garbage collection. In order to dive deeper into garbage collection as a whole, we're going to need to talk about variables, which we'll talk about in the next video.